Chapter 2, Tools of a Healthy Diet, Screencast 1. Now, I usually refer to this part of this chapter as the alphabet soup chapter. And the reason why is we're going to see a lot of different abbreviations. And so it's really important to make sure that you have an idea of what these are about. The first thing that we'll be looking at are what known as the dietary reference intakes, or DRIs. And what this is, they're actually a set of guidelines for a large number of nutrients. And one of the things, when we keep these in mind, how are they categorized? How do they differ? And it really is based on life stage. So things that are taken into account are age group, gender after age 9. And notice, once again, it's after the age 9. They are focusing on pregnancy and lactation, and those are periods of time when there's going to be a change in needs of nutrients. So one thing when we look at these, they should basically be applied to dietary intake averaged over a number of days. So this is not something that's just a day thing. This is something that should be kind of achieved really across the lifespan and the recommendations that we're looking at. The first are estimated average requirements, or EARs. Now, these are defined basically as the daily nutrient intake amounts estimated to meet the needs of half the people. This is a very big distinction, half the people. And so one of the things that these are going to excel at is evaluating the adequacy of diets of groups. So EARs are not really designed for an individual. The EAR is actually set for 17 nutrients. And as I indicated, they're really about meeting the needs of 50% of those in a given life stage. So these are definitely not ideal to use for an individual. That's going to be a very, very big distinction. Now, if I had to pick probably the most important, and this is bias, the recommended dietary allowance, or RDAs, and you've probably heard of these before. These are the daily nutrient intake amounts sufficient to meet the needs of nearly all individuals, so 97 to 98%. So here we are now looking at something that is best used on an individual basis. So the amount is based on the nutrient's ability to prevent chronic disease, and rather than just prevent deficiency. So that's another big distinction. But if I wanted to identify the most important characteristic of RDAs, is the fact that these are what you want to use when you're looking or working with an individual. All right, very important. Now, adequate intake, or AIs, the daily intake amounts is set for nutrients in which there is no real good research to establish an EAR. So this is kind of adequate. So these values are based on observed or experimentally determined estimates of the average nutrient intake that maintains a defined nutritional status. So should be cover the needs of 97 to 98% of individuals. So adequate intakes can also be used for individuals, but there's not enough support for them as there is for the RDAs. So RDAs, once again, so far are really what we should be using if we're looking at an individual basis type thing. Now, this is also going to be important here because some of these can actually be toxic in large quantities. A majority of these may be minerals, such as iron. Iron can be toxic in large volumes if we look at our fat-soluble vitamins. And so tolerable upper intake levels, upper levels or ULs, this is the maximum daily intake amounts of nutrients that are not likely to cause adverse effects in 97 to 98% of individuals. So once again, these are designed for the individual along with the RDA and AI. And keep in mind here, this is chronic daily use. So if you hit the upper limit for a day or two, that's really not what we're talking about here. So what here is, these are basically designed to protect those who are more susceptible in a healthy population. So once again, a lot of these are going to be geared towards a healthy population. The other thing that's important here is this is an upper limit or an upper level. It's not a goal. Okay, so that's another really important distinction when we are looking at these. Now, this is a really important chart because it's talking about the relationship of DRIs to each other. So kind of want to look at a couple of things here. So on the x-axis, we've got increasing level of intake. Over here, percent of healthy population at risk for inadequacy. And over here, percent of healthy population at risk for toxic. All right, so we've got a range here, and notice what's kind of happening here. There's kind of a sweet spot between the RDA and upper limits. All right, so here we're basically looking at really zero risk, all right, for inadequacy, and at the same time, zero risk for upper levels or toxicity. So notice the AI pretty much lies between the RDA and the upper limit. Notice here when we look at the EAR, okay, so it's basically not as good as the RDA. So this shows a really, really important relationship here that we kind of want to keep in mind here between those. So there's really kind of a sweet spot. That's really where the adequate intake kind of falls into play. All right, and notice these are the three that pretty much are designed or used for individuals: the RDA, adequate intake, and the upper limit. Now, another important variable is estimated energy requirements. And what this is the average daily energy need for each life stage group. Now, we have 3 primary energy yielding nutrients, and we throw alcohol in there. We don't consider alcohol to be a nutrient. Most of the calories in alcohol are empty. And generally, what we do know, when we consume energy above our needs, that excess energy is going to be stored as fat. So our body's going to hang on to energy for a rainy day, and it does so in fat. So one of the real concepts we'll talk about a little bit later is balance, energy balance. Do I want to be in a positive balance, or negative energy balance? The majority of individuals in the United States are what we refer to as a positive energy balance. And what that means is there's more energy coming in than going out, and you're going to see a net gain in weight. When you talk about a negative energy balance, that basically means the energy expenditure is greater than the energy being consumed. Now we're going to see weight loss. So this estimated energy requirement is important because it can be used to promote a healthy body weight. Now, it's not often I'm going to ask you to memorize percentages, but I will ask you to memorize AMDRs, and we'll introduce these along the way. Okay? These are set for the energy yielding nutrients, so carbohydrate, protein, and fat. There also is an AMDR for essential fatty acids, but I'm really just going to focus on the big 3, so carbohydrate, protein, and fat. And these are ranges. And what they do, it's an intake associated with good health, all right, and also a reduced risk of chronic diseases such as type 2 diabetes, cardiovascular disease, and so on. Now, one thing that is going to be important is the appropriate use of the DRIs. So some of you may actually be going into a nutrition program to be a dietitian, and so some of you may actually be working with individuals on diet planning and things like that. That's one of the uses that the DRIs are actually designed for. So working on diet planning, and generally the goal here is, because remember, if you're working with individuals, you want to work on use the RDA or the adequate intake, because remember, those are those that are designed to actually be set for an individual and not a population. Upper limits are there for a reason, so you do not want to exceed, okay, the amount that's set for the upper level for that particular nutrient. And they're also designed for healthy people. Generally, when we look at the DRIs, they're not really appropriate for those that are undernourished or those individuals that may have some underlying disease or health condition. So that is something to keep in mind to use the DRIs and use them appropriately. Now here, this is just an overall chart, and this is something that we've kind of talked about along the way. So I'm not going to spend a lot of time going over this, but this is a good reference where you can actually see in one place all of the DRIs and their best uses. So that's something to keep in mind here overall. Now this is another really important chart here because it's looking at what happens with increasing nutrient intake. So generally we do know if there is an insufficient intake for a chronic. So once again, when we look at these intakes, generally we want to look at long term. And the reason why a lot of nutritional issues related to deficiencies actually take a relatively long time to manifest clinically. So that's also something important. So what we do know is that an insufficient intake below the RDA or adequate intake, that's going to cause a deficient state, poor health, and in some individuals, some type of a disease state. The sweet spot, once again, the RDA and the adequate intake. So that's actually the level that you want to be at. And generally, this allows everyone to maintain good health based on the nutrients that they are ingesting. And then if we look at the upper limit, so once again, we're talking about chronic use. So chronic intake above the upper limit can actually lead to toxicities, and that can have a significant impact on health, resulting in some type of disease or so on. Now, this is probably a concept that I really want to reinforce. And what we're looking at is nutrient density. And a big issue when we look at weight loss, obesity in the United States, it really boils around empty calories. When we talk about empty calories, they basically have no nutrient value. Soft drinks, high sugar fruit juices, alcohol, they fall under this category as far as being empty. And so we want to look for foods primarily that are nutrient dense. Because once again, if I have a food that's nutrient dense, I'm getting a lot of nutrients, but there's not a lot of calories associated with that. So that's really important to keep in mind here. Okay, so generally when we look at empty calories, those are going to be food items that are high in sugar, and really we're talking about here are simple sugars, so monosaccharides, disaccharides, and fat. There's not a lot of other nutrients that are present, and as I indicated before, a lot of these are unhealthy snacks, so soft drinks, chips, cookies, candy, they all fall under the category of empty calories. So this is a really, really good comparison. If I look at an 8-ounce soft drink, that's just a cup. That's a serving. We'll talk a little bit later about servings because one big thing that has happened is change in serving sizes. So we'll spend some time talking about that. Hardly anyone ever drinks a 8-ounce pop. Okay? Now, what we're looking at here is comparing the nutrients between 8 ounces of a sugared soda versus 8 ounces of fat-free milk. And notice the only thing that you're getting here out of the overall soft drink is calories, energy. Okay? Now, if we look at what's happening with the milk, so not as many calories as we see in the soft drink, but also look at what else we're getting. Okay? And this is in comparison to adolescent female RDAs. So almost, a little under 20% protein, about 20% vitamin A, some vitamin C, thiamine, riboflavin, niacin, calcium, and even some iron. Okay? None of that here. So you're getting all of this with less calories. So kind of bang for your calorie buck as a way of looking at this particular comparison here. But this is a really important thing to keep in mind. Even if you're working on your own food choices, you want to go with those things that are higher in nutrients as opposed to high in calories. So this is something we'll come back to pretty regularly.